art you have to refine over time. But any questions on what we've just talked about? So I gave, a set of sample diagrams within this, and I think you should have seen these in the video. And I talked about some cases where, balancing feedbacks may be desirable, maybe undesirable, cases where it leads to lock-in, where it can't change the situation because it pushes back against us when we try to knock it. Other cases where we want people to be resilient, we want them to be able to resist perturbations, we want them to be robust under adversity and stress, etc. And similarly, reinforcing feedbacks have sort of situations where they can be undesirable vicious cycles or virtuous cycles, cases where things are going in a direction we feel are good. There's some weird disjointing. Seth, do you think we might be able to borrow you for just a second? I'm getting this weird clipping effect here.
This is being shifted over on the left or the...
Oh, okay. So I don't know how to frob that. How do we frob this to decrease it? Any idea?
Not offhand.
Okay. Do you want me to unplug it and plug it back in?
Sure, you can give that a shot.
Okay. Okay. Yeah. So maybe not during this session.
Thanks. Well,
Fantastic. I note that.
Wow, those are the best problems.
Yeah. Thank you very much, Seth. Really. So balancing loop. Something's off. You try it again, and a bit of persistence. So yeah, a bunch of different types of components.
Maybe we should ask him to stay in the class.
Yeah, it's not a bad idea. But one thing I did have here were some tips. I'll put these at the sort of thing that I discussed with Causal during that lecture that I could help resolve. No? Okay. So I had some tips. Question? No. Okay. So I had some tips to give here on causal loop diagrams that I think I showed during the lecture you would have seen, but maybe I didn't emphasize as much as I like to for this class. Generally speaking, the variables often phrases, sort of quantities we can think about, maybe observe, maybe not observe, but in principle we know what they mean. It may be a quantity that's hard to quantify directly. Trust, respect, admiration. Those may be things which we know are very, very important, but actually ratifying them and describing how to measure them and quantitate them, how to create a meter stick, as it were, for it it may be challenging. But we know they're important, so we put them as part of these diagrams. It's important these diagrams be inclusive in that regard. They should be at least ordinal. What do I mean by ordinal? So there needs to be some ordering, so you could say this is more than that, right? You may not be able to add them together, but you can at least say, okay, there's more of it or there's less of it. Links should be able to have, so you can say, if A increases, all other things being equal, B will increase. For that to be meaningful to say increase, it can't just be a categorical variable, something, male, female. It's a categorical variable. Here we want something which has a sort of level of positivity. One thing is clearly greater than another. Links should have unambiguous polarity, so we need to be clear about what that means. So it's not just It's not just sort of some general concept, population. You should actually make it clear, like population size of population count, or something like that, so it's clear. Color would be another example of something. It's not clear. It's either ordinal or there's an obvious polarity. Maybe those go together very clearly. But color, like, okay, this color is greater than another color. Blue greater than red. Well, no. I'd say the saturation of color. Yeah.
You can say that grayscale color is
Okay, yeah. That's fine. So you could say grayscale color. You could say the saturation level of the color. In other words, it's a brighter color or less bright. That would be fine. But that's imposing. These are tips to take often what's your initial sort of thoughts about the diagram and make them more precise. So make it specifically clear for others to think through, and often for yourself to think through. So if you're thinking color, great. Just when you say more color, help me understand what that means. Does it mean it's brightness, or does it mean that it's whiter or blacker or something like that? That needs to be unpacked. Yeah, Kirk.
If you have a variable that's two-dimensional,
Yes.
like location and encoding,
Right.
would you encode that with two different variables, or?
It's a good question. You could, or if what really matters is, so
You
there's
would
lots
switch
of
the distance, but I'm saying it's not so much the distance.
Right.
You have to keep it two.
right. So you'd want to think of is the complete location something you need to think about representing separately, or really what matters is proximity to some resource. Right. Maybe the appropriate quantity to use is proximity or something like that. Does that make sense? Yeah. This is something that a lot of people from engineering, computer science, or other technical backgrounds have trouble with. It's a constant blind spot. Ladies and gentlemen, by our training, so I'm trained as a computer scientist and electrical engineer, and I find it very easy in my early schooling to think about systems that are technical in nature, the underlying technical components of it, but it's devoid of kind of human agency. It's devoid of the human feature. It's devoid of the sort of interactions, perceptions, and beliefs, and attitudes, and motivations, or what have you. And it turns out that often what we're dealing with in this class are at the least so-called socio-technical systems. In other words, they may have a technical component. You take the transportation system. Transportation system, for a lot of engineers, it's easy to think it's all about, the angles of roads and structural strength of overpasses and, carrying capacity of rail, different aspects of rail transport, different modes of transportation, whatever. We can describe this all at a technical level. But, at the heart of it, you can't leave people out of the equation and have a meaningful description of how that system will react to different policies. Same thing with computer projects, computer systems. This is a classic problem. Every few months, sometimes several times a month, I go through Denver International Airport. Denver International Airport, like Kuala Lumpur International Airport in Malaysia. Those are two airports which exhibited, which are quite nice airports now. I've spent a lot of time in both of them, but they exhibited real problems in rollout. And if you can go in, and it's absolutely fascinating stories. I have books which could fill you in some of the details if anyone's interested for Denver. But a lot of the issue was that, I know for Kuala Lumpur, I remember it very vividly, there was a failure to take into account the human sides of things. Okay, so there's this attitude you'll sometimes hear come up among engineers and computer scientists that, the system works. It's people's problem that they can't use it. Oh, it's their problem. Okay, they made all these mistakes entering the data into the system. Well, It's the people's fault. You know, it's not the system's fault. It's the people. Now, mind you, it may be that the system is totally non-functional if even one error is entered into it. But you say, oh well, it's the fault of the people. It's not really the system. Well, folks, a lot of people, you look at, you know, MIT's, for example, civil engineering department. It's entirely, much of it is just motivated by this notion of a socio-technical system. This idea that we have to consider the people as part of the system. People are not independent of the system. If people get frustrated and are not going to use that interface anymore, or are going to just be sloppy because they don't care anymore, that's going to have a big impact on how it turns out. If you're dealing with a system that has a usable interface that's easily understood and that invites people to kind of work with it, you're going to have the whole system behave much, much more sensibly and more effectively. And so you need to think about personal motivation and personal attitude and belief and trust as a component of the system. And if you don't do that, you're leaving yourself just wide open to failure. You could have the most pristine, beautifully characterized engineering idea, but if ultimately you're unable to persuade people to use it, or they end up misusing it with misunderstandings because you haven't phrased it, it could be, might as well have been useless, and it may have wasted a lot of time, might have caused net harm. So, you know, part of this whole idea of systems thinking is putting the person back into the system, okay? Recognizing that we are part of the system. Sometimes the model makers are part of the system, and conceptualizing those feedbacks, which involve not only the so-called system itself, the technical components that we as engineers and computer scientists are often thinking about, but also involve the human feedbacks. And those feedbacks often involve perception. Perception is not instant. It takes time. It takes time to build up trust, and much less time to lose trust, for example. And you know, the feedbacks that you draw with these diagrams, you need to sort of push at yourself sometimes, particularly if you're from certain backgrounds, like highly technical backgrounds, to ask yourself, you know, am I missing some human agency here? Am I missing some of the human element that could form important feedbacks that are neglected? Because some of the things which went wrong in those airport cases are human feedbacks. People got disgusted, unused, etc. And it just fed on itself. They got more and more confused, and when they got confused, they got, you know, demoralized. And when they're demoralized, they're less likely to enter the information, you know, on time, and you get these sort of vicious cycles, which end up, you know, dooming it for a while. So, you know, with Denver Airport, it you know, ripped bags apart and spewed their contents all over the baggage carousels, and you know, there was big problems in the project delivery, and so they delivered the actual system late, and so they had to route the baggage manually for a while, but they had forgotten to build tunnels for the carts to go through, because they assumed that it would be built on time, so they hadn't built a failback option, and as a result, you know, the baggage was often incredibly delayed, and so probably impacted airports' willingness to relocate there. Kuala Lumpur Airport had big issues with its IT systems. So people are part of the system. This is part of the systems thing. When you think about your diagram, ask yourself, push yourself, where are the people? So, you know, I remember doing one project involving water infrastructure. It's really easy. Engineers connecting together pipes to connect this reservoir valve, this water recycling system to that desalination system. Oh, it's all great. But where are the people? Where are the people who may hoard water if they get worried they're going to run short of water? Where are the people who could store up laundry for only a certain amount of time before finally doing it? Where are the people that may choose not to opt in to the recycled water because of concerns about healthiness up front? Think about putting them in there. because that's the way you avoid getting just struck in the face by the obvious human element after the fact. So mega diagrams, I think I showed late that diagrams here can get very sophisticated. I don't know if I got to these. No, this is all system dynamics. This is like a brief glimpse of system dynamics here. So forgive me, but there's actually this is kind of a big diagram building up of sort of a bunch of relationships related to vaccination and related to sort of changes during outbreaks like social distancing and risk perception and attention to hygiene. These diagrams can get pretty big. And if it gets much beyond this is about sort of as big as it can get with me feeling fully comfortable with it. You want to start thinking about breaking it into sub-diagrams, abstracting out certain elements or what have you. There are diagrams that are very, very large. The Foresight Institute has mega diagrams related to obesity, and they can be useful sometimes. For example, they use it to label, and I wish I had a picture of this handy. I had it in one of my earlier lectures. They use it to kind of label where different interventions try to intervene. They lay out all these feedbacks, and they show these interventions focus on this area, this intervention focuses, and that can help you identify gaps. Oh, there's a gap. No intervention is targeted this area or that area. So sometimes it can be useful, but you have to really zoom in to see it. Label loops. See if you can give loops a nice name. So I would advise you, it's not a requirement, but I would suggest that you look at the Sturman book, Business Dynamics, and I think it's chapter 3 of that book. Okay? So it's one of the recommended books for this class, and it's Business Dynamics. And it's chapter 3 is my recollection of the chapter for causal diagrams. And if I were you, I'd take a look at that. It has some great examples, including some with labeled loops, and some of those are built up, and they're discussed in an admirably clear way, characteristic of the author. So I would take a look at that if I were you. Another issue is this whole issue of distinguishing perceived and actual situation. So there may be one actual situation, but people rarely have the ability to act on the true situation, the ability to react on a perceived situation. And that perception takes time. And that's often one of the key features of human feedback. There's a time delay, and therefore there's time to adjust, and therefore there's sometimes oscillations. In my lecture I discussed targets of balancing loops, things that lead it to aim for a certain point, or things that are kind of the point of stasis towards which it goes. And planar graphs, so it's not required, but it gets to be kind of messy with lots of arrows across each one. Okay, any questions on these? And maybe we could look at a diagram or two that you folks have come up with. I'm hoping. Any questions? No? Okay. So let's stop this.